So the next unit is called polynomials. Now this is going to sound a little confusing to start with, but you'll get it. So it's just mostly all the language that we use, that if you can understand the terms, then you will be able to understand polynomials. So a polynomial is one term or the sum of terms whose variables have whole number exponents. So I'm just going to write one out there. 3x squared minus 5x plus 6. So that is a polynomial because we're subtracting or adding terms and the variables have whole number exponents. So that's important. Terms are numbers, variables, or the product of numbers and variables, meaning they're separated by the subtraction and addition. So this is a term, this is a term, and this is a term. So this has three terms. And finally, the coefficients are the number multiplied by the variable. For example, the coefficient of 3x is the 3 that's in front, or negative 4x squared is negative 4. So those are coefficients. So you should pause the video and write down those definitions because you will need to remember those. Okay, the term with the greatest exponent determines the degree of the polynomial. So 3x squared plus x plus 2 has a degree of 2 because of the highest exponent of 2 in the whole polynomial. It has 3 terms though, but the degree is 2. So if we look at this example right here, 2x exponent 9 plus 3x exponent 7 plus x exponent 4 minus x squared minus 9 has a degree of 9. And that's because of this 9, not because of that 9. That 9 is called the constant because it doesn't have a variable. But there are 5 terms in the polynomial because they're all separated. 1, 2, 3, 4, 5. Okay, if you hear a monomial, it only has one term, such as 5a exponent 4. That's a monomial, one term. Binomial has 2, so maybe 2r plus 5. And a trinomial has 3 terms, so maybe 3x squared plus 4x minus 7. So it's a trinomial. They're all polynomials though. Okay, so pause this and we'll see if you get those definitions by answering the questions: how many terms, what is the degree, and what is the coefficient for the x squared term. So pause the video. Okay, the answers to those questions are: how many terms? There's 1, 2, 3 terms. The degree is the highest exponent, so degree of 4. And the coefficient of the x squared term, which is this one, so the coefficient is 2, positive 2. Okay, on this one you have 1, 2, 3, 4, so 4 terms. The degree is the highest exponent, so 11, and the coefficient on the x squared term is 147. So if you didn't get those, go back and review the definitions. We're going to look at one more thing in this video, and that's modeling the polynomial using tiles. Okay, so x squared is a big square because it would be like x times x, so that makes it x squared. A white one's going to be negative x squared. One skinny narrow one is x, and the white is negative x. My constants, or just my numbers, are represented by these little squares. A negative one is white, positive one is red. Okay? So if we model the following expression, it just means we're going to bring out the blocks that show what the expression is. So negative 2x squared, it would give me negative 2 of these, plus 3x, so 3 positives, and negative 1 constant. So that's just what my polynomial would be modeled. And that's important because we're, in the end, going to end up adding, subtracting, multiplying, dividing with the models. So I'd like you to model these, maybe draw them in your notebook and use the tiles actually, and then show me, and I'll make sure you're on the right track to model these expressions.